Hi guys, my name is Raul Ochoa. I'm a robotics engineer. I've been a robotics engineer for quite a few years now, and in this presentation, I'm going to talk about what is ROS2, when to use it, and why you should be using it in your robotics journey. Now, at the end, I'm also going to provide some installation instructions so you guys can have your system set up and ready to continue on your journey of robotics. All right, so let's get started. What is ROS? If you guys have been looking online, search the term, you might have encountered a lot of information on ROS2 and ROS1. Well, the important thing to know is that ROS2 is the successor to ROS1. We're going to be talking about ROS, and whenever I say ROS, I want you to understand that I'm using that term interchangeably, but I basically mean ROS in general. Now, because ROS2 is out there and it is a newer version, just assume that I'm talking about ROS2. You should focus on ROS2 in your journey of robotics, as ROS1 is going to be uh, barely mentioned now. It is almost irrelevant. You might still find a few things online that talk about ROS1, but it's going to be very minimal, as mostly everybody in the robotics industry uses ROS2 nowadays. Now, ROS2 and ROS1 have the same core concepts. The only big difference is the ROS2 has more and better features, as it is the newer version of ROS. All right, so ROS2, or the Robotic Operating System, what is it? It is a basically middleware, right? So it's middleware or software that enables robotic applications. Now, if you look at these three platforms, the different robotic platforms on the screen, what do you see that's common between all these three robots? Well, if you think about it, they all probably have motors. They all probably have similar sensors. Maybe they move in a similar way. Well, one big thing is that most likely they're all powered by ROS2, right? So ROS2, it's going to help you by providing a standard, all right, standard that's going to be used in these robotic applications. Now, this is important because that's going to allow different teams to possibly work on the same robotic application and understand sort of what's going on with um, less complexity than it would take if everybody was using different standards, working on the application in different ways. If somebody here's coded before, you might have worked on somebody else's code, and if they weren't following a specific standard, it might have been very complicated to understand what they were trying to do. Just because you understand code or a specific standard doesn't mean other people are going to follow it. And when you have to work on their applications, you're going to notice that it's going to be a lot more difficult if you don't follow specific standards. Now, ROS2 also allows for modularity that can be used in any robotic platform. And this in hand is going to enable faster robotic development. So a little bit on that. What do you mean by faster robotic development? Well, if we look back at these platforms again, one quick example, let's say we talk about this robotic arm. Now, if you're trying to make this arm move from one position to another, let's say this arm maybe had a gripper at the end, and you want that gripper to actually be placed somewhere in 3D space, right? Maybe you want it to move and grab a specific box that might be standing next to it. Well, it might sound very simple just talking about it, but it involves a very complex system of different things, different skills are going to be used to accomplish something like this. It is going to involve a lot of math, probably physics, electronics, a lot of different things, right? So instead of having to learn all this mathematics, learning what inverse kinematics and all these other concepts are, you can use something like ROS to enable you to develop these movements, these applications, by using some of its libraries. So don't reinvent the wheel. ROS2 is going to allow you to not focus on low-level technical things that already exist. And by using ROS2, you can just focus on high-level functionalities and just work on your use cases. So a lot of these things, like I mentioned, uh, mobility, allowing the robot to move a certain way, there's already libraries that other people have used for things that are commonly applied in robotic platforms that you can just take advantage of by using ROS and focus on what you're really trying to get your robotic platform to do. Now, when to use ROS2? Well, ROS2 might not be the right choice for every single platform, right? So one thing that you should consider is the platform that I'm trying to develop a low complexity platform. What do I mean by that? Well, maybe your robotic platform, all it does is have a small arm that moves back and forth. Well, for something so simple like that, ROS2 might just be overkill. It might just be something that's unnecessary. It might be too much effort to install ROS2, and if there's no other uh, future updates to this platform, if it's going to be something simple, then ROS2 is just not the right choice for it. Now, if your robotic platform involves multiple sensors, functionality, or high complexity, then ROS2 can definitely help you out, and you should consider ROS2 as a solution for that. Now, how does ROS2 work? Okay, well, ROS2 allows for modularity, like I mentioned before, and it does this by allowing you to get your code and separate it into blocks that we call nodes. Now, these nodes can also communicate with each other with ROS2 communication. So let me kind of explain this with the diagram that I have on the screen right now. If you look at that robotic dog, it has different things on it. It has different sensors, it's got cameras, might have other things on there, like that arm that's mounted on top of it. Now, when you program this code, you're going to develop code for the camera. Maybe the camera can detect when humans pass by in front of it, or it can look out for sensors or markers on specific areas of its environment. So you would code all of that in the camera node. Now, maybe you also have to code something for the navigation, right? Teach it how to walk, teach it how to move around its environment. Well, then you can code that in the navigation node. Similarly, you might have some sort of autonomous feature, right? You might be able to enable this robotic dog to move on its own or perform different tasks on its own. Well, then you can code that and put it on the AI node. And then maybe you want to have another node that's called control that's going to allow you to maybe manually control this robotic dog with a controller, joystick, something like that. Now, where does ROS2 communication come in? Well, let's say the navigation node requires something from the camera node. Well, then it can communicate with it and just pull that information from it. Maybe it also needs information from the AI node because there's some sort of intelligent algorithm that the navigation requires to be able to move. Well, it can connect to that with something called a subscriber and then be able to pull just the data that it needs and similar with the control. So this is how ROS2 enables different nodes to communicate and talk to each other to grab the data that it needs to perform its actual tasks. So this is how ROS, overall kind of works with nodes and the communication that ROS2 enables between them. Now this is really good because these sections of code or these nodes can also be reutilized later on with a different platform. All right, so if the camera needs to detect humans, right, and then you decide to build a different robotic platform, then you can get this node and use it for that other platform without having to recode everything again. So that's where the modularity and really the real cool thing about ROS2 comes into play. Now, some of the benefits of using ROS2, I already mentioned a few, like the modularity piece with the nodes and the simple communication that allows you to expand on the functionality of whatever robotic platform you're working on. But there are a lot of tools that come with ROS that you'll learn in the future. So use those. Also use the plug and play libraries, like I mentioned. You don't have to learn all these very extensive and complicated math algorithms to be able to accomplish certain tasks. There's a lot of libraries that you can just plug and play and use. So you don't have to waste years to learn, to be a very knowledgeable mathematician to be able to create these algorithms. Most likely there will be something out there that you can just learn in a couple of days, learn how to implement it with ROS, and still, you know, accomplish the same goals of getting your robotic platform to do what you need it to do. Now, one other thing that's very important to know about ROS2, and I think it's a very amazing feature of it, is that it's language agnostic. And what do I mean by that is that you have all these nodes that you developed or that you coded. They don't all have to be coded in the same language. So let's say you created the camera node on Python, but then later on you coded your navigation node on C++. They can still communicate with each other. So that's a very cool feature of ROS, that you're able to develop different nodes on different languages, and the communication is still enables them to talk to each other and work together to accomplish whatever you needed to do. Now, another benefit or a good thing about ROS2 is that it is open source. So with that, you're going to find a large and active community out there. If you ever need to find more resources, help, you'll be able to search online, and there's going to be plenty of information out there for you to find and utilize. All right, so I hope this brief explanation of what ROS is, why you should use it, and when you should use it made sense. Now we're going to start with the installation process, but before we do that, there's a few prerequisites that we should make sure that we have checked before we start. By now, you should have Ubuntu 24.04 Novel Numpad installed, and on the system that you have this on, you should have an internet connection because you will be downloading and installing software. So those two are really the important things. An extra is if you do have some basic knowledge of Linux, the operating system, then it's definitely going to help you out, but it is not necessary. With the steps that I'm going to provide for the installation, you should be able to install the tools perfectly fine and learn how to use Linux on your journey of robotics. All right, so let's go ahead and get started.